So the first question that we have is coming from section 1.4 on page 126. This is question number 13. So to save a little bit of time, I would encourage you to get your book and open it up to the problem. So go ahead and pause the video if you don't have the book with you. It's going to take me a little bit too much time to go ahead and write it out on here. So I'm going to read it out loud. This is number 13. The base of a triangle is 1/3 as long as its height. If the area of the triangle is 24 square meters, how long is its base? So with a geometric problem, I always encourage to draw out the figure. So since they're not really specific as to what kind of triangle to use, I'm going to go ahead and just sketch a right triangle. Okay, so from here, I'm going to go ahead and label this out. And we know in this instance that the base of this triangle is 1/3 as long as its height. So in this case, the next question that should pop up is, okay, if I know that the base is 1/3 of the height of the triangle, all I need to know is the height, and then I can easily solve for the base. Unfortunately, the problem neglects to give you this value. If it did, then there wouldn't be the point of having a problem here. So since I don't know what the height is, I'm going to go ahead and say that it's going to be equal to this mystery number x, and I'm going to label it here. So from here, I can kind of continue, and I know that the base now is going to be 1/3 of the height. When you hear 1/3 of the height, the word of is a key word for multiplication. So I'm going to write this as 1/3 times x. Okay, so from here, we are then talking about area. So area of a triangle, if you recall, is going to be 1/2 times the base times the height. So if you recall this formula, it becomes pretty straightforward that you're going to have to do a plug and chug here. Okay, so again, consult the problem and pull what information you know. We know that the area of this triangle is going to be 24 square meters. We also know that since 1/2 is a constant, it just naturally flows into your setup for the problem. As far as the base, we've identified it over here as 1/3 x, so we can do 1/3 x, and then our height is going to be x. So we write that. From here, we go ahead and we clean this up. I note that I have an x times an x right here, so I'm going to simplify that down. So now I have 24 is equal to x squared, and then we also have this 1/2 times 1/3. Well, I can multiply constants together. We've been doing that since elementary school. So we would multiply this to get 1/6. Okay, and from here, it should start to kind of reveal itself to be just a basic problem where our goal is to isolate x to one side of the equation. So in order to handle this, I want to get rid of that 1/6. So I would suggest going ahead and multiplying it by its reciprocal, which is going to be 6/1, or just 6. And what I do to one side, I must do to the other. Algebra is all about your checks and balances, okay? You need to maintain that balance. So if we do that, this will cross-cancel itself out and reduce to a 1. This gives me x squared. And then 6 times 24 will give me 144. Okay. Now I have to figure out, okay, how do I get x by itself, or how do I break this exponent, this square? Well, hopefully, as I've been chattering, you have been saying, well, you take the square root of both sides. Because again, the exponent of 2 is going to cancel out with the root because they're inverses. So if you take the square root of 144, then we would get plus or minus 12 is equal to x. So really, when you have this solution here, you're saying that x, which we had already denoted was the height, we're saying that the height either equals 12 meters, I believe, is the unit that we're working with. Yes, so 12 meters, or the height could be negative 12 meters. So this is where you want to pay close attention to the context of the problem. there's no way that you can have a measurement that is negative 12 meters. So we know that our height is 12 meters, and now we can go ahead and figure out the base. Our base is going to be 1/3 times x, which we had already indicated before. So what we're going to do is we're going to substitute 12 in for x because we solved that. And 12 times 1/3 is going to be equal to 4. So this is 4 meters. All right, so there you go. 4 meters is your solution.